Yeah, welcome back to AWS DevOps Logistic YouTube channel. Today we are going to discuss about Kubernetes series is going on. So Kubernetes we are running with Terraform. So yes, today's topic is DaemonSet. Okay. So what DaemonSet is in what is DaemonSet in Kubernetes? All will see in this. Okay. So let me share my screen. Yashwant, are you able to see my screen?
Not yet, sir.
No?
Yeah, no, it's no, it's available.
Okay.
No, it's
So this is DaemonSet. What is DaemonSet? Daemon, you have heard about this DaemonSet in Docker, right? Okay.
yes, sir.
Daemon sets are like replica sets. It's a kind of replicas. Okay. As it helps, you deploy multiple instances of pods. Okay. Multiple instances of pod. This is a simple abbreviation. Get try to understand this sentence. It's like a daemon set. Daemon sets are like a replica sets as it helps to deploy multiple instances of pod, but it runs one copy of your pod on each node of your cluster. Okay, you understood this point? It runs one copy of your pod on each node in your cluster. Okay,
Yes, sir.
yeah. So whenever a new node is added to the cluster, okay, for example, if we can see for example this. So I got this from GitHub. Okay, this is I found it from the GitHub. Why can I lose this, right? I got good documentation from GitHub, right? So daemon set, how many types are there? Totally three types we have. First one is daemon set, replica set, and deployment. These three are there. Okay. So whenever new node is added to the cluster, okay, for example, one new node added to the, this is one cluster, 1, cluster 2, cluster 3, cluster 4, cluster 5. For suppose I have a 5 clusters. Okay. Whenever a node added to the cluster, a replica of the pod is automatically added to that node. Okay. Replica of the pod, okay, automatically added to the particular node, like this. Okay. And when a node is removed, the pod is automatically removed. For example, node removed, right? If this node removed, automatically whatever which we have created the pod, that will be removed also along with this node, right? So the daemon set is ensure that one copy of the pod is always present in all nodes. You understood this point? In the cluster, again I'm just trying to repeat, the daemon set ensure that one copy of the pod is always present in all nodes. One copy of pod, one copy of pod, one copy of pod is always present in node. Okay, nodes in the cluster. Okay. So so daemon set use cases. Okay, what are the use cases? How many type use cases? I just used this when see this. Is it visible clearly? Now it is fine, right?
Yes, sir. Yes, sir. Yeah, yes.
Okay, I'll try to bring more big picture. See, now it is fine, I think so. Okay. So daemon set use cases. So what I would like to say is, let's say if you would like to deploy or monitoring agent or log collector on each of your nodes in the cluster. Okay, so you can monitor your cluster better Okay, daemon set is perfect for that. But if you want to monitor a cluster, okay, if you want to watch, if you want not, it's watch. If you want to watch your cluster, if you want to watch your cluster, okay, so daemon set is the best for that. Okay, if you want to monitor your cluster better, daemon set is the perfect for that, as it can display your monitoring agent in the form of pod in all the nodes in your cluster. Then you don't have to worry about adding or removing agents from those nodes when there are changes in your cluster, as daemon sets take care of you. You understood? Did you understood this topic, this point, Yashwant? What you understood from this?
Yes, sir. Like monitoring each and every pods can be monitored, sir, using daemon sets.
Yes, by using daemon set, what by using clusters, it will be watched by
Clusters. Yes, sir.
clusters. Okay, so cluster, so in the cluster, okay, so for example your nodes in the cluster, so you can monitor your cluster better, entire cluster, right? Inside cluster only we have pods, correct?
Yes, sir.
So these pods we need to be watched, where we need to watch in the cluster. So cluster watched by daemon set,
Daemon sets.
correct?
Yes, sir.
Okay, so yeah, that's it. You understood, right? We don't have to worry about this, because in this cluster will be taken care, for whatever the cluster, this cluster will be watched by daemon set. Okay, and earlier, while we are discussing about the Kubernetes architecture so long back, okay, we learned that one of the worker node component, hmm, that are required on every node in the cluster is a queue proxy. You remember, right? Queue proxy.
Yes, sir.
That is one good use case for the daemon set. Okay, that is best use case for the daemon set. Okay, so like whenever so like one of the worker node component that is required in every node, one worker node component required for in every node, correct? So in the cluster, it is a group proxy, maybe that is queue proxy. What is the purpose of queue proxy? Hmm?
Like to see any unused pods or this.
Queue proxy is not for communication.
Oh, mm, yes, sir. It is for communication.
Yeah, so another use case is for networking.
Yeah.
Okay, another use case is for networking communication. Okay, so that we will see in, especially we have networking part class. In that networking class we will see, so why, what is the use cases we are using daemon sets. Okay, so but you can remember, until then you can remember this one use case is for this. Okay, like
Communication and networking.
communication and networking and queue proxy kind of. Okay, so next one is networking. Okay, creating a daemon set is similar to the replica set creation process. Replica set, it's a kind of that, almost similar. Okay, it has nested pod specification under the template section, and selector to link the daemon set to be to the pods. I will show you. So the other use case is networking. I already mentioned here. Okay, I got a good document from the GitHub. I need to thank to the GitHub. So this is, we are lucky to use this. Okay, so another use case is for networking. Next, see this, can you see this? Daemon set.
Yes, sir.
Creating daemon set is similar to replica creation process. For daemon sets we have start with API version kind daemon set instead of replica set. Here kind we earlier we used to use replica set, but here in daemon set we can mention daemon set. There it is replica set, it is daemon set. Almost similar definition, only file definition will be changed. Understood? You see this, can you see, is it visible?
Yes, sir.
In the replica set, if you observe manifest file of replica set, so you see this. Okay, in this kind, what is this, too much. Okay, so version, see API version apps v1 same in daemon set also. Kind of daemon set, kind here in replica set it is a replica set.
Replicas.
Metadata is common. Okay, so monitoring daemon spec, selector match labels, selector match labels, app same, template same, right? Metadata labels and app name, this one. In other specifications, container, this specifications is for containers, same, correct? Only the change is
Yes.
this one kind. Here we are using daemon set and this is correct, replica set and daemon set. These two only change, almost similar, correct?
Yes, sir.
So to create that, manifest file, how to create that, right? So to see the daemon set whether it is created or not, you can use this. So after creating that I will give you the command. So kubectl, excuse me, the command is kubectl get daem daemon sets. This is the command. Okay, and to describe, okay, if you want to describe daemon sets, the command is kubectl describe daemon sets and daemon set name. So after this one daemon set name will be there, right? So you need to describe that. Okay, so this is the command to list daemon sets. Kubectl get daemon sets. For more details you have to use whatever daemon set will get, that daemon set we have to mention. If it is the monitoring daemon set, yes, monitoring daemon set, this related, correct? So next, what is a, so you can see like this. Understood? How does it works?
Yes.
So we have to we have to see the labs, so after setting up tomorrow. Okay, so how does it works?
Yes.
If you are asked schedule a pod, okay, on each node in the cluster, how would you do? So this is the question. So in one of the
Like
previous, like,
using nodes.
correct. Okay, so if you
Yes.
are, if you are asked to schedule a pod, okay, on each node in the cluster to schedule, okay, to schedule your pod on each node, how would you do? So this question you may get in one of the previous classes, I think. So we might have discussed that we could set the node, okay, node names, right? Node names
Yes,
were
sir.
using node selectors. Okay, properties on the pod bypass that schedules and get the pod is placed in the node directly. So that is the one approach. And then the other one is on each pod set, each pod set the node name property in its specification before it's created. Okay, and when they are created, they are automatically land on the respective nodes. We have seen this, right? So that how
Yes.
how it is used to be until I have I will make it a big picture. See this? So default behavior was version 1.12. Okay. So after that, so it got changed node affinity by using node affinities. So the version got changed scheduler. Earlier default behavior v1.12. From v1 version 1.12 onwards, the daemon set uses the default scheduler and node affinity rules. You understood this? Can you?
Yes, sir.
So default behavior till v1.12,
V1,
but
1, 2.
after
Yes, sir.
v1.12, after v1 after version 1.12, the daemon set uses the default scheduler and node affinity rules.
Yes, sir.
You understood? Hope you understood this point,
Yes, sir.
right?
In
Next.
description, we have seen node affinities or something like
Correct.
that.
Yes, correct. So this is these two versions used actually. Normally, the default behavior was there. Okay, but after
Yes,
version
sir.
1.12, this came into the picture. Daemon set is the default behavior. Okay, like default scheduler, like daemon set uses the default scheduler for node affinity rules. Correct. So don't confuse. We'll see one by one. Okay, in practical, if you do practically only, then you can understand this theory. How much you read, it doesn't make any sense until you do practical. Okay, this is another topic. One second, let me make it big. This seems good, right, for you?
Yes, it's enough.
Okay, right. So multiple schedulers. What are the multiple schedulers? So basically, so your Kubernetes cluster can schedule multiple schedulers in the as the same time. But so before this, we have only one scheduler, default scheduler. Correct? Right.
Yes, sir.
So
Yeah.
but we can do our own custom schedulers, right? So how kubelet functions? One second, Yashwant.
I'm audible, sir. My voice is breaking, sir.
That's why I think the network issue, I think so.
Hello. Sir, not audible.
Yashwant, can you hear me? Hello. 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 Yashwant, can you hear me now? Hello. Yashwant, hello. So multiple schedulers. Can you hear me? Hello. Yashwant, hello. Yashwant, hello. Oh God. Just give me 1 second. Hello. Yashwant, I think there is some network issue. I think so.
Yes, sir.
There is some network issue. One second. Still you are facing same issue?
No, sir, it's clear now. The screen is not shared.
Okay. Okay, one second. Try to share. So there is some network issue. Try to adjust. So is it fine? Can you see?
Yes, sir, no.
Yeah. So multi-scheduler. So multiple schedulers. So in earlier of this course, like class, we have talked about architecture and kubelet functions as one of many
The
control
voice
plane
is
of
clear, sir. Screen is not visible yet.
I think maybe some it will take time. I think so. Mm, okay, what to do then?
No, so voice is also getting break, sir.
Okay, just give me 1 second. Mm,
There's a network lag.
I think network issue. One second.
And now I can see.
You can see, right?
Yeah.
There is some network issues. 1 second. Yeah, can you see now?
Yes, sir.
Yeah, the kubelet relies on the kube API server. You know that, right? So for instructions, one for instructions on what port to load on its node, which was based on the decision made by kube scheduler, which was stored in etcd data. These are all things we have discussed earlier, and no controllers and no etcd cluster. So which means number of controllers and number of etcd cluster. What if there was no matter all? Okay, so what if there is no matter of nodes, right? So what if you are all alone, like see by yourself? Okay, right? So cubes like kubelet can manage a node independently, right? On like earlier we have seen the starting architecture we have
Yes, sir.
discussed, and we have the kubelet installed. Okay, so so how kubelet used to still you are you able to see screen? All right.
Yeah, sir. I'm able to screen in multiple schedulers. It is.
Then it's fine. So yeah, this cube scheduler actually, this one, why it is not able to move? Yeah, fine here. Yeah, that's fine now. Right, this one cube scheduler default behavior, okay, actually. So but for example, if there is no cube API server or anything like that, so the one thing that kubelet knows to do is create pods, but we don't have API server here to provide pod details. So we know that to create a pod, right, you need to okay, you need the details of pod in the pod definition file. But how how do you provide pod manifest file? So to create to the kubelet without a cube API server, can you configure a kubelet to read the pod definition files from the directory on the server designed to store information about pods? Kubelet periodically checks this directory for files. Like for example, this cube API server actually we had earlier, right? So initially this is default behavior, but
Yes, sir.
our own by using our own. Okay, we can create our cube schedulers. This is custom. Okay, custom cube scheduler.
Yes, sir.
This is, if you can say, if it is 1, it is 2, 3. So these many cube schedulers we can able to create by our own. Okay, right? So this is the concept. This is the multi
Yes, sir.
schedulers concept, is that only to create your own custom cube schedulers. Okay, so let's see, I'll try to scroll it down. So how to deploy additional cube scheduler by using this imperative command is there, right? By using this imperative command you can uh, try to, 1 second, yeah, see this, deploy additional, like if you can see this, give me 1 second. What is this, why it is changed? Yeah, now it is fine, correct.
Yes, sir.
It is not working fine today, correct. You see this, deploy additional scheduler. How? So this is the command. Okay, so this is imperative command. So by using this you can schedule. See this cube scheduler,
Yes, sir.
right? This cube scheduler
Like we will
you can keep.
in Google, sir. Like we have used wget and URL.
Yes, so this is
First,
for
we should use
release.
that.
Yeah, yeah, first we
Okay.
have to use this
Okay.
for default one. This is default one. So when we
Okay.
will get this, we have already done this, right? So while we are
Yes, sir. Like.
setting up,
Uh,
right? For setting up, this default will get,
yes, sir.
but for custom you have to use this, my custom scheduler,
Okay. Okay,
like
sir.
this, I understood. So you have to use this, like,
Yes, sir. Yes, sir.
you have to change your name like this. For custom you have to use this method, imperative method, correct. So I'll show you again. So see this. So for example, you cube scheduler, my custom cube scheduler, change, see this difference, correct. So how to deploy your additional cube scheduler in the kubeadium? Okay, if you run those, if you run the above command, okay, so you will get manifest file like this only. Okay, this is cube scheduler, like this, default one. Okay, and your custom one, like this. You have to use API version 1, kind of metadata, name would be your wish. So namespace is like this, and container, this you have to use release. Okay, and image should be like this. Okay, and cube scheduler, cube scheduler. Okay, default one, custom one, only the name is changed, that's it.
Yes, sir.
Okay, next, what is how to create? See this, kubectl create hyphen f, so my your name, manifest file name. Okay, so after that, to custom scheduler, to create definition file, new selection called so and so, this scheduler name, API kind metadata spec container, so scheduler name. See my custom scheduler. Okay, custom scheduler, how? See this PART-1, see PART version 1 of Nginx. So scheduler name is your own scheduler, like this. It is easy. Okay, something like this. How we have to check this means by using this kubectl get pods hyphen hyphen namespace equal to cube system, out of which you can select all these things. So new things whatever you have mentioned, my scheduler, custom scheduler, the same name you can able to see here, right? Correct, something like this.
Yes, sir.
So this is how we can use daemon set and multi schedulers. Okay, default max to max will use default if it is there any requirement for the multi schedulers. So at that time it will be used. That is the reason I'm trying to cover this. This is not that much uh, very important, but yes, whenever it is requirement, whenever you get requirement, definitely it is important. You understood? So at that time you can use this. So how kubectl will get events, you can see all these things scheduled. Okay, view scheduler logs by using this command kubectl logs. So my custom scheduler hyphen namespace cube hyphen system. Okay, these are all commands. We'll see tomorrow then. Okay, so
Yes, sir.
and you do practice using some like using uh, cluster IPs. Okay, node IPs, using node IPs, how to access from outside with a different images. Okay, not only custom
Okay, sir.
images, you can use different images and how to access without using load balancer. You earlier you have used load balancer, right? Without using load balancers you can use.
Yes, sir. Once load balancer we have used, and once node select node port.
Yeah, so node selectors, right? This one only, right? Sorry, not
Yes,
this,
sir.
not this cluster IP. Where is that? So I am also not following one document, that is issue. Node selectors, where we have mentioned cluster IPs, all those. Okay, I'll make it one document
Services.
altogether. Services on all. I think
Yes, sir.
I'm also using different document. That's why it is a big problem. So I will make it one document. Okay.
Yeah.
So try to do practice. So so if I get free time, so we will practice on this. Okay. Right.
Okay, sir.
Okay. Nishant, take care.
Yes.
Bye.
Yes, sir. Thank you.